Okay, we're going to work on number 2. Find the zeros and give the multiplicity of each. Well, again, we're going to use the zero principle, and we can start with number 30, exercise 30 at the end of section 3.4. And by the zero principle, you can see that either x plus 2 is 0 or x minus 3 is 0. So the two solutions are x equals negative 2 and x equals 3. And so we'll call those the zeros. We could also call those an x-intercept or a root. That's roughly synonymous. They have a slightly different meaning. But we want to find the multiplicity. This factor of x plus 2 is raised to the third power, so negative 2 has multiplicity 3. And x minus 3 is raised to the second power, so the 0, 3 has multiplicity 2. And those are the zeros and multiplicities of exercise 30. Let's look at number 34. Here, it's not so clear, but it is factored. What I want to do is put it into a nicer form. Notice first that 2x plus 1, that's the same as 2 times x plus 1/2. So I can rewrite that factor as 2 cubed times x plus 1/2 cubed. And also 9x squared minus 6x plus 1, that's actually a perfect square. That's actually 3x minus 1 quantity squared. And I can factor out that 3 squared times x minus 1/3 squared. And so I'll have a 3 squared times an x minus 1/3 squared. And this will let us write out the zeros and their multiplicity very easily. The 0 and the multiplicity, well, you can see that negative 1/2 is a 0, and that factor is raised to the third power, so it has multiplicity 3, and positive 1/3, that is raised to the second power, so that has multiplicity 2. So you may have to do some factoring and solving to find this, and we're going to see that that's even more the case in 37. Let's clear out some space, so do some erasing, and we're going to work on number 37. Let's bring that over here. The thing that we want to do is to solve the zeros. We want to solve f of x equals 0, or x to the 6th minus x to the 5th minus 2x to the 4th equals 0. Well, I see a common factor. X to the 4th is a common factor for all of those terms, or monomials, and the quotients are x squared, minus x, and minus 2. And this quadratic factors, we have x to the 4th. It factors kind of nicely. If you don't see why this is true, you might want to get some factoring practice. But now we can read off the zeros. There's a 0 of 0. If you input 0, the output is 0. 2 is a 0. If you input 2, the output is 0. And there's a 0 of negative 1. If you input negative 1, the output is 0. And we want the multiplicity of each of them. Well, 0 is, that factor x is raised to the 4th power, so it has multiplicity 4, whereas x minus 2 and x plus 1, those are just simple factors, so they have multiplicity of 1. And let's stop there and go on to the next problem. Thanks.